Good morning, folks. I'm going to do a relatively short stream today. Got just a little bit over 2 hours right now to work on some things. Ended up having a pretty busy day yesterday. Had to catch up on a couple things this morning. I think we're going to do just a couple hours of stuff on the world model formulation. And then I'm pretty damn tired today, honestly. I got one meeting later. So we're kind of just going to look at some stuff, and then tomorrow's going to be the, 1 second, I close that calendar. Yeah, tomorrow will be the main day for actually trying to make this stuff work. But who knows? Maybe we actually make some progress in just a little bit of time today. We'll see. Page back to this. And seriously, no CUDA. Hang on, you guys. Second. Yes. Stop. Up 47 hours? Hmm. Away Windows. Alright, so there is our container. And yeah, here's our Dreamer thing. Cool. We were using Cartpole, if I recall. Okay. So in my mind, right, Cartpole's a really, really simple problem. And this should have been solved a long time ago, basically. Like, it shouldn't be this fiddly. We shouldn't have weird problems going on. And, like, you see there, it is doing better than random, but, like, not by much. So, I suppose the question is, like, what is the minimal set of stuff we have to do? Their toast? Welcome. What's up, dog? Not much what's up with you. Welcome. Yeah, I had a quick haircut. I had a little time yesterday for that. Lemons are toast. I don't know. I was thinking they're more like croissant. This should just totally work by now, right? Like, pretty much anything, if you sneeze in the direction of Cartpole, you should be able to solve it. So the fact that I've kind of messed around with world model stuff for 3-ish days now and not have it, like, solve Cartpole is really sketchy. So what do we do about this, right? I mean, there are a bunch of different things we could look at for this. It's not like with or without sampling. Still's a weird thing. Still weird either way. We have like at least a little bit of evidence because This is the world model training, right? So if you just take this thing and we uncomment these lines here, right? So this says that the instead of hallucinating full trajectories, you're hallucinating like one step. This trains, right? Huh, that used to train. Maybe I just mega broke something. It's not like it was good before, even when we had this, though. Okay. Next state pretty easily. If you're only wanting it to predict one next state, which would be, okay, let's just make sure if I just uncomment correctly, right? So this is one next state predict. This is what that is. Gonna PR SSM stuff maybe tomorrow. Solving carpol kind of learns breakout, like it's locked in local maxima. Added exploration. There shouldn't be any like that basically shouldn't be a thing. And SSM stuff, that's a pure architecture change, right? We have here, this is like basic RSSM integrated with the world model. Super bizarre. How did I end up breaking this? Rep loss. MX loss. And it still doesn't help. Okay. Stuff did I mess with? I messed with the losses, right? Welcome, YouTube folks. This is hacking on, well, attempting to get something Dreamer-esque working. It does really bother me though that like we don't even have something basic when I literally implement like stupid vanilla Q learning and you'll immediately solve part poll with that. So it's kind of screwy that we still don't have anything really to show on the world model stuff. Instruction loss, dynamics loss. Welcome, Scorio. Uses LSTM for initial training and then uses gates to transfer to SSM. Like, does it do anything? There should be, I mean, all these methods, right? You have, like, you get all these papers where it's like, oh, yeah, it just beats everything. And then, of course, you go and actually implement the thing, and it just, like, underperforms your baseline. Solved cart pull in 200k steps. 200k steps. Like, not in the puffer implementation, right? With like default hypers. Because 200k steps in the puffer implementation, it's like you don't even get data back by then on whether you've solved the task. Right? Because it's like 200 steps per horizon. Wait, hang on. How's that possible? Because you have, whoops. You have, like, was it 8192 environments? Um, you get like you're not getting that many steps worth of data, even see if you've solved it in that number of steps, unless you dramatically mess with the batch sizes. Custom params. Yeah, so the thing is that, like, I'm sure there are also params that you can solve it in 200k with the baseline, no? I guess maybe I'm not sure. Maybe not. You'd want to see it working on the harder tasks, though, for sure. I think Breakout is like the simplest task for which doing Breakout better is usually a decent indicator of something being, like, generally useful. Dev. Do I have to explain to you why that's not a good branch name? Rename that shit, but otherwise I'm happy to look at it. In here. Oh, we have a lot of PRs. Oh, screenshot. I see. I thought that you named the branch that. I'm gonna say. Let me look. Yeah, okay. I assume you mean some other screenshot than this? Or you just trolling? Wait, what am I looking at? Oh, this? Thing. Okay. 7k SPS. That's something screwy. I'm gonna look at it for sure when you're ready with the PR. What did you mean by the title? Uh, we have. I've been burned by world models just not working in the past, and we're giving the stuff another chance because we're out of other promising directions. And I think that it is the case that they will work. They're just very janky. 100k? Okay, that's better at least. It's definitely possible. I'm gonna need to actually, like, look at the original paper on this on those as well, if it's like S4 or whatever. But for now, how did I break this thing? What is going on here? Super unstable. I suppose we just go through carefully and like see if I can find any problems. For the world model, right? Get the real observation. We run this forward. Gives you previous, you get previous action, okay. This is the real action. So, yes. Encode H and X. The hat is just encode H and Z, H and Z. Reconstruction as well. Word terminal. X is hat. The rewards, you're aiming to predict next reward, so this is correct. Terminals. I believe this is fine as well, right? This is just dynamics and representation losses. I didn't expect to have this be the situation when I sat down to work on this today. I didn't realize I'd broken it like that. Iphilly's world model. I've actually been meaning to go drop by in SF. I heard Justin's there now. Justin was the first person I ever worked with in AI. He mentored me while I was in literally high school. I still actually have the poster from that. I did like a whole bunch of really, really janky stuff around early version of Visual Genome. Like, no, it's really, really weird actually that this version doesn't even work. What the heck could I have possibly broken? It might just be worth looking through change logs actually for this. Ugh. Do this first. I guess this is the latest thing I did was this KL loss, right? If it was this KL. Hmm. There is something screwy with the loss. Yeah. Alright, let's figure out what it is. Why are these so negative? They go find the let me go find the other version. The KL lost in this. Apply stop gradient to posterior logit. And then this is the exact same thing. How's this thing getting applied anyways? Prior post. Okay, so this is supposed to come from the RSSM somehow. This prior and post. So imagine step gives you prior. And then ob step gives you... Oh. Wait, no, ob step gives you both. The heck? Where's prior? Okay, so prior comes from the imagination step. And carpal 13 to 15 seconds at 100K. So that's like way better samples than what we have now. But the thing is, I know you can solve cart pull in like almost no steps. It's just that our implementation is optimized purely for wall clock, right? So it's like a 3-second wall clock or whatever or less. I would definitely want to see like if you can get it to work on at least breakout. That's kind of the minimum bar for there being something to an approach. I'm doing cart pull with this based on a fairly high degree of confidence that this should at least be feasible. And cart pull just being a sanity check. I'm not actually going to say, oh, it works based on cart pull. It's just like a bare minimum sanity. That makes sense. The heck? Budget. I don't like image O linear. Where the heck is the distribution? Wait, this gives you logit. This gives you logit before the distribution, right? And then they do... Wait, then they do get dist on both of these. Okay. And then they KL div. Kinda weird. Also, how is... I don't understand how the KL div is supposed to be... max? Rep loss in 1.0. It doesn't make sense to me. What is the scale of this thing supposed to be? This is positive. Be either sign, okay. Designed for longer ends. Robot arm end. Handle task switching. I would definitely try it on a lot of our standard M's that have been used in benchmarks before first. Because, like, trying something on a new environment is always sketchy. Because you just never know how well the baseline is optimized on your new env. I definitely do that. Yeah, I don't understand how these two fit together. At the risk of getting completely bad information. Let me think if I think it should be expected. Get like a complete mismatch, right? Swapping log argument. Do I have them backwards? I don't think so. Inputs targets. In log, wait, tensor of arbitrary shape in log probs. Tensor of same shape as input. Aren't you supposed to KL div the distribution, not the samples? Wait, how the hell does this work? So you are calling get dist on the logits. And this is doing, I mean, this is giving you one hot categoricals. Right? So wait, why is it like this? Does anybody understand? You're taking KL div between samples of a one hot instead of just between the logit distribution. I just passed logits. The logits need to be... No, I didn't just pass logits, I passed the samples. Yeah, okay. I'm just trying to sanity check this thing. There's something's like very wrong with the loss. Honestly, this could be enough to be it on its own. Like, maybe once we have this fixed, it'll work. We'll see. I'm exhausted today, my gosh. I got back from the city with, like, terrible migraine. Basically just passed out. I got up this morning, I still did my 10K, I did my lifts. And then, like, I was just starving. So finally got myself a meal. But, I don't know, I'm still just a bit off today. I don't think I have these backwards, right? Input, target. Should be applied directly to samples. Am I just being completely stupid somehow here? In a way that I'm not seeing? I'm using it directly on samples from a categorical, which is a valid probability distribution. Are you supposed to detach it, though? I think there is, like, there's some stop grads that I'm not using. Let's see. Oops. Tab. So they do this everywhere, though? Why would you do this? You stop grad. Oh, no, no, no. This is fine. Oh, wait. They do stop grad on... Well, there are no parameters from the sample, right? So get dist, that doesn't actually have any parameters to it. So it actually shouldn't matter if you do it before or after, right? But I think that's actually the same. What is the scale? KLDiv is supposed to be positive, isn't it? Actually, let's look up the other way. Okay, so yeah, it definitely shouldn't be negative, but it somehow is. The log probability. 1 hat categorical, right? And then the dynamics loss. Softmax or straight through output rather than on log probs. Oh, because it wants log probs for the input? I see. Comment on what it's doing. With tons of comments. Well, the thing is, if your code doesn't suck, you won't need them. The problem is most code just sucks. Like, when you actually read a nice, clean code base, the comments are honestly a distraction most of the time. So it's like kind of just a band-aid patch for major skill issue. With obvious exceptions, right? Like, if you're doing super heavy algorithmic stuff like this, then yeah, sometimes. But in this case, I think I just missed something. Yeah, I missed that this is log prob and the target is not. Wait, what are you supposed to do? Because I don't take... Let's see what they do in this. So it's supposed to be get dist, right? And then they do KL dist. So I get dist. Yeah, that's from distracts. I don't want to get into that. Um, you just need to take a log of one of these. Yeah, what are these? Because these aren't logits, right? Oh, are you supposed to be? No, you are actually taking 1 hot, right? It doesn't necessarily make sense to me that this is how it's done. Like, should I just take the logits from the distribution and not the sample? That doesn't seem to be how it's implemented. That stupid model's so slow. Yeah, you see, these are definitely... It's called get dist on this, and they get this one hot. So I don't know why... Why do you take KL on the samples rather than just on the distribution? Oh, because the distribution is defined by the sampling process, right? Kind of weird, though. So I guess then the thing would be that the dist operator here... Yeah, dist has a KL div built in, which is in, like, dist racks or whatever. Hate Jack so much. One hot in here. Doesn't have a KL div on it. What is a world model? Something like Genie? Not exactly. So the difference between this and something like Genie is that the world model is being learned live from interaction data. You're not just training on a static data set. You actually have to train on live interaction data. So you're simultaneously learning a policy that interacts with the environment and gathers better data, and a world model that tells you what's going to happen next. And the thing that we actually care about is not the world model, right? The thing we actually care about is the agent policy. The entire point of the world model is to help us train a better agent policy. So, according to this, and this is what I would expect, honestly. We can try this. Oh, wait, am I guess because they don't call sample, right? Yeah, they don't actually call sample here, so they're doing KL between the distributions, which probably reduces to KL between logits. Which is also why the sample... Yeah, that's also why they have the sample. Okay. So you don't even need this crap at all. So I can just do like this, right? Code and dynamics. this. Like this, right? Then we do hi man, would love to do some Q learning. What kind of project would you suggest me? For the sake of doing Q learning or for the sake of like trying to get RL to work? Because like Q learning is as a base algorithm, it's a very bad algorithm, and you actually have to bolt like a ton of stuff onto it to make it at all work. Like on policy RL is a lot easier because the core algorithm is not any more complicated and you don't have to bolt on as much stuff before it actually works. I would just suggest in general checking out my RL guide. I've kind of put all of my stuff into this. So this is a complete reference on intro RL up to even advanced stuff. Rock 4 good. We're near. I mean, if you ask me, none of the models are really good, so yeah, I really do not use LLMs anywhere near as much as most people these days. I'm not the person to ask. I sometimes use it to sanity check stuff, and half the time, even then, it just wastes my time. This was kind of decent because it caught something in the docs that I didn't notice, but then I have no idea if this is even remotely reasonable. I did actually implement DQN the other day, Weston, in Puffer, and like, yeah, you can get it to solve cart pull, I guess, but it's not a good algorithm. It's very fiddly to actually even bolt all the other stuff on to make it work. But yeah, and it's kind of ironic that like, in some sense, Google sucks now because LLMs exist and have polluted the internet, right? What do you think about this? Q learning is not yet scalable. What? I think I've been linked this before. Oh yeah, so off policy RL is just bad. Um yeah, I actually understand why this is. So on yeah. Okay, so this is correct, but it's kind of missing the point. I'll do a quick segment on this. Why not? I'm gonna try to get the math as correct as I can. Keep in mind I don't do. Actually, I'll go grab it from Sutton so I get it right. I don't know how I managed to misspell both names. Bootstrap thing. Where's the Q function formulation? I'm trying to get the math right for this. I guess I can just get it from retrace, right? Well, I can probably do it well enough from this. So, here's the issue, right? The normal Q formulation, it's like it's a one-step bootstrap, right? Yeah, here it is. So it's like R X. Right? It's something like this, right? And this is a one-step bootstrap because you're only looking at a difference between a transition and the next transition, one transition, next transition. You get the reward plus the discounted maximum value. So this idea will show up in on policy, off policy, everything. But you end up doing something like, reward at T plus gamma R one plus N. Then you bootstrap like Q. I believe this is how you would do it for Q function. I know it's the value function for on Paul, so it should be the same. Actually, it might be the max here. I think it is the max, right? I think it is max. Something like this. But anyways, so the problem here, you want to bootstrap over a segment, okay? But the problem is that the policy has changed, right? So this data is off policy. And you go, oh, well, it's an off policy algorithm. It's supposed to work for that, right? It works when you do this because this is a one-step bootstrap. So you're literally just taking, if you take this action in this state, then the path from there is as follows. When you do this, you are you're basically telling it, you're going through what if the Q function follows a specific path of actions, or the policy follows a specific path of actions that's no longer a likely trajectory under the current policy. And you have to correct for this with something like importance sampling. And in fact, I have this in the on policy case, but for the off policy case, you'd use something like retrace. This is also in Sutton and Bardo as well, but the explanation I'm going to give you is not the damn thing. Okay. Yeah, so this is the thing that I just gave you, right? This is gamma to the T. I think this is like a weird recursive form, actually, isn't it? Oh yeah, yeah. This is like this is a recursive form because what happens here, right, is that these all cancel out. It's so difficult to present this stuff when the math is written differently in every single possible place. I wonder if Bardo has a better, Sutton and Bardo has a better. Where the hell is this? Yeah, it's in eligibility traces. Okay, so this is more like similar to the thing that I wrote out, right? So reward t plus 1, gamma, reward t plus 2, so on and so forth. And then gamma n, they have it as a value function or whatever here instead of a q function, no big deal. This is your n-step bootstrap. And then the key thing here, where they have the important sampling. They're doing it here with the... Where's it? This is like a subtle but very important point that I discovered recently. Well, this kind of shows it to you. The idea, though, is that why does nobody even ever have a clean mathematical form of this thing? This is why it's so hard to, like, learn anything. Literally nobody ever has a clean formulation of it. It's actually kind of a difficult exercise to make sure and get all your notation correct. The idea is quite simple. The math is sort of a pain. I guess this is the best we're going to get. The idea is that you're going to weight your samples by a probability ratio of how likely you're going to be to take the action under the current policy versus under the policy that you used when you were collecting the data. And what happens with this is that you can write this out, and this should actually give you a stable n-step bootstrap update. But the way that it actually does this is just by downweighting data that's too far from the policy that you collected the data with. So, like, the way that you actually make off policy work with long horizons is by ignoring the long horizon data. You do not have this problem in on policy learning. So that is actually the technical reason that this happens. And this is a band-aid patch. Right? This is like a super band-aid patch. And the horizon reduction end step return, for instance, like this is a band-aid patch because you have to also do importance sampling, and you end up just sort of ignoring your data. So far, like, yes, we don't actually, this is true, we don't have this. And you actually don't even necessarily need this to be the case, because if model-based RL works, model-based RL lets you do, it basically lets you do unlimited on-policy RL with respect to the world model. So you don't actually need to solve this problem necessarily. Like, there are viable alternatives. I didn't understand this fully even a couple of months ago. It's taken a lot of going through really complicated stuff to figure that out. Welcome, Kyoko. Adding ramping noise on stagnation, a good idea. You really, if your base model is any good, like, you shouldn't have to hack the state space model formulation in a bunch of different ways to make it work. It's kind of just flailing. Go away, bot. Hey, Spirit. Alright, and then you no longer have this good thing. Really? This? Thus, Q learning is not very useful. I've definitely, in the last couple weeks, I've been more bearish on it since the... I mean, I did a fair bit of, like, off-policy stuff experimentally in Puffer in the last week or so, last 2 weeks, and it really didn't seem very promising. Some messages not arriving? Yeah, X does that. I'm also on YouTube and Twitch. I think Twitch is the best about not dropping messages, but sometimes they all do it. To be fair, it could also be Restream being weird. Why are these logits like this? Kind of weird. I guess not. Huh. I have MSc in computer science. My chances are MIT. Recommendation letters. Sound researcher in Oracle. No scientific. Yeah, the no scientific publications is the thing that's going to get you. Like, pretty much everybody doing a PhD, at least in the US, at the top few institutions, it already has, like, scientific publications. Like, maybe if you happen to have, like, very strongly overlapping research with a specific professor. That's the tough bit. Like, I'd basically been doing full-time academic research for 3 years already, before I got to my PhD. Oh yeah, also the other thing is, typically in the US, you don't do an MS before your PhD. Like, it's different in Europe, but like typically you don't get a master's before your PhD. And yeah, definitely if you have done a master's, then you should have research as well. Like, it's different in Europe. I don't know if there are like different considerations given to European students, but at least yeah, in the US that wouldn't fly. Church and I don't know what publication is like in that area. Norms could be different there potentially. I mean, the best thing to figure out and unpublished in a journal conference, like the best thing honestly to do is to like actually find and like get to like talk to the students of a professor who's doing stuff adjacent to your work and then potentially get a meeting with the professor from there. Because otherwise, if you don't have standout stuff, it's like very difficult just being in a random pile of applicants. Yeah. I don't know. My deal was like I didn't have a 4.0 from my university, but then again, you're not necessarily expected to. Um, but like I had been like I published my sophomore year, my first like solo author NLP research. I did some computer vision research that had manuscripts but wasn't published. I did some RL at OpenAI, and then uh, the professor I'd worked with at OpenAI. He went to be a professor, so obviously he already knew and worked with me. And the way it works in the U.S. is like if a professor wants to work with you, they just pull your application from the stack. Right? That's kind of how it works, at least for PhD. And I also got in at CMU, um, like without any contacts. CMU is like a very meritocratic place, so like if you have good research, that typically happens. But then I was not going to be in a spot where I was going to like work with a professor I didn't even know, right? So obviously I go to MIT. Q-learning guy, hopefully rest survive. Q-learning not very useful. Policy wing on policy training. Well, that's part of it. That's more advanced. The main thing that's going to be a pain for you for Q learning is like the comparison is not DQN to PPO or something. It's going to be like Rainbow to PPO. And Rainbow is a super messy algorithm where you have to like bolt on a ton of stuff before it remotely works. Whereas PPO is a much simpler algorithm that really you only have like one kind of difficult thing to implement before it just works. And you have way better references as well. That's probably the main consideration for you. It really depends on your goal, right? Like if you're trying to learn this stuff in this space, I would just follow my guide. Like RL is legitimately an area where the most productive thing you can do when you're learning is not necessarily to implement the algorithms from scratch because like it's not like, oh, I'm studying basic new algorithms, let me go implement like depth first search or whatever. Um it's the algorithms are very fiddly and they're very minor details that matter a lot. They're not based on anything other than just like empirical testing. So like actually I generally suggest people implement new environments and new problems and use them with existing high quality implementation rather than try to make their own implementation. Like making a good implementation, even if a common RL algorithm, is actually a pretty advanced thing to do. and an idea on how to improve Q learning. Well, the thing is, actually, it's likely to work because the problem with, like, oh, how do I improve Q learning is that Q learning itself is such a weak benchmark that basically anything will improve Q learning. Like, coming up with something that improves Q learning actually is not meaningful on its own. You need to have, like, an optimized version of one of the much fancier off-policy algorithms that's extensively tested, and then you can see if it improves. That's the problem. To be fair, plenty of stuff gets published of the form like, yeah, I did this on top of DQN and it makes it work better, but, like, it's not good research. Really not good research. Okay, so, I mean, this kind of works now. I have no idea if we're doing this remotely correctly. Ooh. Okay, that's still super unstable, but that's better. Yeah, that's way better. Okay. I would suggest reading some of my guides because a lot of this context is, like, not stuff you're gonna get out of Sutton and Bardo or, like, standard resources in RL. It's, like, stuff that the people who've been in this space pick up on over time. And I try to put a lot of that knowledge out there as best as I can. This actually works. Am I so tired? Holy hell. I got what, like, should have been 10 hours of sleep. Traveling always messes me up. Okay, where do we go from here? Probably want to log some additional losses, right? Yeah, so these are, like, way too small, right? These are, like, way too small. Ask a few questions on this. If I do this, does it make a difference? Go to bed. Looks like you're making progress. Yeah, thanks. It makes progress. It's just very unstable, I think. Yeah, it's gotta be like something where it's fighting the quality of the world model or something. This actually does look like it scales with compute, though, way better than before. Which would make sense. Now, if we can just make it stable... Let's figure out the loss scale, I think. Yeah, let's figure out the loss scale. Go get myself a drink as well. Hydrated here. Figure out these this loss scale thing, because something's weird to me here. Notifications. Oh yeah, from the stream. Scale seems really off, right? You can see it jumping. And it crashes. Jumps up and it crashes. Total KL, not per dimension. But also, we don't know. Are these all supposed to be sampled separately? Look at this for a little bit. Have your RSSM. You get your mystic. This is, yeah, okay. Returns everything. Yeah, ask away. I bet. Useful, do you think models? Um, I don't think that I could be wrong on this, but I don't think you're going to be able to use them for RL. Because, like, I think that the world model formulation where you're training the world model jointly with RL, that makes sense. I don't think you can just take the world model training away and do RL on that and have it work, because you're literally RLing the model to poke holes in your world model. And that's like a closed loop in RL, because, like, you're also training the world model. You got, like, this back and forth process, which kind of makes sense here. But that's not the case if you stop training the world model. Like, technically, yes, with a perfect world model, it makes sense, but what the heck does a perfect world model even mean for, like, arbitrary environments? Like, not even well defined, much less obtainable. Yeah, you can use them for other purposes for sure. But I don't see fundamentally how you like use them as a replacement for an RL environment. Which is one of the things DeepMind has said that they want to do. That part doesn't make sense to me. Possible I'm missing something, but I don't think so. Yeah, latent. Please star puffer. Do star puffer. It helps me out a lot. Do you ever look into... Thank you. Bet is our resident advertiser around here. Storing the repo actually helps us out a ton. That actually really helps. You ever look to other ML research? I mean, occasionally I look at stuff. There's a lot to keep up with. I look to other things for inspiration for sure. But we have a pretty clear path forward, I think, with a lot of the stuff we're doing with Puffer right now. The only uncertainty in my mind is like pretty much whether this is going to be the way to get us high sample efficiency RL or not. Like even if this completely fails, like I still have stuff I can do with Puffer. It limits us a little bit, but like there's still a ton of stuff we could do. Even if it turns out, like, which doesn't seem to be the case, that sample efficient RL is just impossible, which it really doesn't seem to be the case, like, there's still tons of stuff I can do. Okay, so this is what we expect. Pretty familiar with self-supervised ML and world modeling into RL, but I'm very new to RL. Yeah, so the thing that makes RL very, very hard, right, is because you're interacting with an environment. There's this whole additional layer. Your data distribution moves out from under you, and there's a bunch of additional engineering. Right? So I've made a huge dent in making that easier with Puffer. But fundamentally, like, except for very large model scaling, like RL's kind of the hardest thing you can do in AI. I've worked in NLP, I've worked in Vision, it's way easier. RL is just like actually really hard. We're making it easier. I mean, heck, we have brand new programmers getting some stuff working. But pushing the state-of-the-art research is still quite tricky. Godsend. That's the goal. I mean, the cool thing with Puffer, right, is pretty much without me even discovering anything crazy new, just literally doing what I'm doing, I can pretty much guarantee that the future of RL is bright. Literally just by if I keep doing what I'm doing, we assume that like I managed to make Puffer a bit simpler than it is now and like relatively closer to like actual flops that you should expect out of your GPU. Like just doing those two things, it's already in a good spot. But of course, that's not all I'm doing, right? I'm also making more breakthroughs all the time. At least fairly consistently. I think this is correct, isn't it? Is it different? What dis dot mean? Latent. Head. MLP head. Yeah, this is fine. I think I have this mostly correct. The other losses in here. Any stop grads? I think so. I guess let's check the check like the decoder loss and the obs loss. Yes, these seem fine. Let's check the decoder loss in here. And no, it's not. I think this is the full method, really. Reconstruction loss does not yet demand more expressive latents. Scale regularizer is overly strong. Okay. Simulation theory, are we just another M? What? I only. I have no idea what that is. A huge match. What? It's a bit sus. Yeah, so it doesn't work without this law, so there's something scaled screwy here. You definitely need this loss, but the scaling is off. Reconstruction loss here. Why do you compute advantage 2 times in the training loop? What do you use each advantage for? I actually don't know why the heck I have that override in the second one. I noticed that the other day. But the idea is that you compute it over everything in order to know what are the highest advantage sections or segments to sample. Because, like, every time you do an update, the advantage changes for literally everything. And then I believe we do it after that to get the advantage for the specific mini batch. I'm trying to remember why the heck. There's something that can change. I think it's the importance sampling ratio, if I recall correctly, that can change. There's probably a way to do it with one loop. Well, maybe not. I do remember there being a reason for me having to do it twice that I couldn't get around, though. Let me see if I can just remember off the top of not off the top of my head, off of a quick look. I remember there being something about, like, importance ratio changing. Yeah, it might. There was a thing with that, though. Oh, am I? Yeah, I'm on the totally wrong file. Okay, so I compute it here so that I can sample, right? And then I recompute it for what? Is it for the ratio? Shouldn't it not change? Huh. It shouldn't change, right? It should change after you step the policy. No, 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 wait, I know what it is. Okay, so what it is... Here, this is what it is. Here's what it is, Carlos. The value gets stale, okay? So you need this new value estimate here. And I don't know why I overwrite it with MB advantages. I think this is an error. But the idea that I had with this originally is that you need the new value function so that you can compute this new ratio. That's what it was. Or you use the new ratio, rather, which is based on the new value. Yeah, because when you compute it up top, right, you don't refresh the value function for every single update, even though this changes from mini batch to mini batch. Like, values is going to get stale, and therefore ratio gets stale. So that's why it was 2 passes. There you go. If you wanted to just ratio, you could eval the model, but why? You can't evaluate it on everything, though, Carlos, because you don't want to do you don't want to have to do a forward pass over your entire batch for every mini batch, right? So the advantage estimation is kind of rough because it can get stale for other data, but at least when you go to do a new mini batch, since you're already recomputing the value function anyways, you can actually compute a fresh advantage for that batch. Because you use advantage to wait the update, and you want a fresh advantage update. You want a fresh advantage estimate. It doesn't really cost you anything to do it either. Like, computing advantage is very fast. The only thing that costs you is doing forward passes through the network redundantly. So this is a trade-off between those two. I mean, this is not bad at the least. Now do I run a sweep, actually? Or is there more stuff I haven't implemented? I mean, this is... If we do this version of it... Fine. Nice trick, yeah. So I don't actually know why I reset the advantage to be the MB advantage, but... The rest of it was because of that. What happened is I left that thing in, and then I probably ran all my tests not realizing I left that thing in, and then went, well, I'm not gonna go rerun all the tests just to delete that one tiny thing. So, I mean, you're free to like take it out and see if it makes a difference or not. So go, good luck with coding. Thanks for all the info. Yeah, of course. I gotcha. Okay, so a couple things. Since you're predicting, here's the advantage normalization. Oh, there is no advantage norm in here, right? Fleeing off. What? Make it better or worse? Like substantially better, no? Test function code name. Yeah, well, you don't generally want that to be the case, right? On ArcAGI. The problem bet is that, like, they're puzzles that rely on human intuition. You can't actually learn to solve the puzzles just via only seeing the puzzles. Like, you'd have to just bake a bunch of visual priors into the model for that to work. Or something. Okay. That wasn't it. The meeting in like 20 minutes. Make this thing more stable. Application loss. We have all this already. I mean, we could just launch basic sweep of this, right? Kind of already. Do this for now. Just set up. It does have the property, at least, of, like, it seems like it does get a little better when you run more compute. Oh, we also haven't done the experience buffer at all. Obviously, that's another thing to do, right? I don't know if that makes it better, though. Maybe. Alright, so this is pushed. I need Neptune token, right? So see, this is when I had it broken. This, yeah. Okay. Oh, did that not get set? It literally just did. Guess it just threw in. Yeah, free token. You get to log some, you can write some logs here. Free logging to free account. Free public account, mind you. All the experiments are public anyways. Good find. Cool. So this will run. Possibly we'll find some good settings. We shall see. I got a meeting to get ready for in like 10 minutes. So I think I'm going to do that for today. We found one problem. I think there are probably more things wrong with this. We're going to need to do the experience buffer, most likely. And there's a heck of a lot of stuff for us to do still, right? But at the very least, it now is in the realm of, like, kind of working. So this is a much better starting point. As long as we have something that kind of works, I'm happy to, like, keep pushing on it. So very good. For the folks watching today, yep, just short stream. I will be here all day tomorrow. I usually stream all day on Saturdays. If you are interested in my work generally, puffer.ai for all the things. Start the repo. Free. Helps me out a ton. Other than that, Discord if you want to get involved. X if you want more RL content. Bye.